Hi everyone, welcome to this video, and in this video we will talk about some exercises from the topic of hypothesis testing, and we're going to look through some of the review exercises from the lectures, and hopefully through this set of exercises you'll be exposed to the motivation on why are we doing hypothesis testing, and at the same time on how do we carry this out. Okay, so now before we start, um, so hypothesis testing, right, is a really long process, right? And so what the central question for this hypothesis testing is that we are going to test our sample mean, right? So we want to test whether the sample mean is within a certain range from the population mean, right? So the thing is that we want to base the population mean, and we want to see where is our sample mean. Is it far enough away for us to reject the population mean, or is it not far enough away to reject the population mean, right? Then again, right, there's many other things that we can test. In our syllabus, we'll be testing on sample mean, but technically speaking, we can test population variance. We can also test on population proportion, right? This will come in further topics as you dive deeper into statistics, right? But currently in our A-level syllabus, we'll be mainly focusing just on the sample mean, okay? And the thing is that, so this long process over here will take roughly 7 steps to do. Okay, so the forward kind of problem would be they will give us the whole context, and we will need to perform the test and to write out our conclusion. So um, so we have step 1, right, which is to define our random variable and the mu, the population mean that we are testing. Okay, okay. And from the question, we need to determine our null hypothesis and our alternative hypothesis, right? So technically speaking, the null and the alternative, right, they are opposites of each other. So usually the null hypothesis and alternative hypothesis are opposites of each other, right? Okay, step 3, we will need to state our distribution of the test statistic under H0. So assuming that the null hypothesis is true, what would be our test statistics distribution? Okay, and we will need to state the significance level alpha. Okay, now generally for forward questions, we'll state this significance level. However, for reverse questions, we will need to go ahead and find our critical region first by using inverse normal to in certain cases, which we'll see later. Okay, so step 5, we will gather the data from our sample data, and we will need to calculate our sample mean value or p value or the critical value, which is the z-score. Okay, so we have 3 possible ways to go about this step. Okay, and in step number 6, we will need to decide based on the sample mean value, p value, or z. Then we will need to look at the bell curve and look at the location of our sample mean and see whether is it far enough for us to reject our null hypothesis. Okay, so and last but not least, we need to state the conclusion of the test in the context of the question based on this acceptance or the whether do we reject our null hypothesis or not. Okay, so generally these 7 steps, we're going to split this into 2 different phases. So this first 4 is actually our setup phase, which we will use to set up the whole situation. 5 to 7 over here is the testing phase, in which we will test and conclude at the end of the test. Okay, so once more, the setup phase 1 to 4, 5 to 7 over here is the testing phase. Okay, so generally for forward questions and reverse questions, the setup phase is the same. However, for forward questions, the testing phase looks like this. For the reverse kind of question, we'll need to look at the critical region and to do a reverse kind of process over here, in which we will see later in some of the questions. Okay, so without further ado, let us start off with review exercise 2. Okay, so that we can roughly see what's the difference between a one-tailed test and a two-tailed test. Okay, so let's read and process this question together. All right, so we have the mass of loaves of bread from a certain bakery are normally distributed. So we'll take note with this very first detail over here, normally distributed, which is very, very nice. Okay, with a mean mass of a loaf being this, standard deviation 20 grams. Okay, the breads are repackaged and the baker claims that the mean mass of the loaf of bread has increased after the repackaging. So this is the claim over here in which we'll process later. To test the claim, we have a sample of 25 loaves. So now regarding, so I will have my own system, up to you whether you want to have your own system. My system is that for population stuff, I will highlight one color, sample, I'll highlight another color, which you can see later. Okay, and then we've got these following results over here. And then assume that the standard deviation remains constant, test at 7% level of significance, right? Whether the baker's claim is valid. Okay, so let us take a look at the quantities again, right? So the mass of loaves of bread from a certain bakery are normally distributed. So which means that based on our knowledge from the sampling chapter, there's no need for us to use central limit theorem. Okay, mean mass of a load is 500 grams. So this statement is telling us that in general, the mass of loaves is around 500 grams, right? So this signifies to us that this quantity over here is a population mean. And this population mean is mean mu. Okay, now then standard deviation 20 grams, right? So this refers to our population standard deviation. The notation for the population standard deviation is sigma, small sigma. Okay, the breads are repackaged and the baker claims that the mean mass of the loaf, so this mean right over here refers to this mean has increased, so this is more than 500. Okay, so this one over here, right, is the claim. Okay, so later we'll see whether does it fall into the null or the alternate hypothesis, but this is one of the hypotheses. Okay, so to test the claim, right, this is a sample, so we collected a sample of 25 loaves, so the sample size n is going to be 25. Now we obtain this result over here because we are testing the sample mean. So this one over here, right, is for us to calculate our sample mean. Okay, and the sample mean is actually the x bar over here. Okay, small x bar. Okay, and last but not least, 7% level of significance. This refers to alpha. Okay, alpha is equals to 7. Okay, so let us recap on the steps on what to do for our hypothesis testing. Okay, so step 1, we need to define the random variable and let mu be the population mean being tested, right? Okay, so now back to this question, let us define our random variable and define our population mean mu as such. So let x be the random variable denoting the mass of loaves of bread in grams. Okay, with the units over here, and mu over here be the mean of x. Right, so this we will define also the population mean. So this is step 1. So technically you don't have to write 1, 2, 3 on the sides. I'm just telling you which step does this correspond to. Okay, so this is step 1. Step 2, state the null hypothesis and the alternative hypothesis. So in general, the null hypothesis contains the equal sign for our syllabus, and the alternative hypothesis contains the inequality, the strict inequality, right? So this is how we would normally set up our hypothesis testing. Okay, so for step 2, our null hypothesis H naught, right, would be this statement over here, the one with the equal sign. So our population mean is 500. Okay, so we are going to verify whether is this the case for the population. Okay, and the alternative hypothesis, so the other one would be mu greater than 500, which is what the baker claimed. So this one, I'm going to write here baker's claim for my own reference. Technically you don't have to write anything, right? I'm just writing this here for my own reference. Okay, so once again, the null hypothesis here typically has the equal sign and for our syllabus, and the alternative one would have the strict inequality. Okay, so this is number 2. Okay, strict inequality or not equal lah. Okay, now let's take a look at the next step. We will need to state the distribution of the test statistic under H0. So we will need to assume that H0 is true, and we will need to get the distribution. So meaning we need to get the normal distribution from this. Okay, so for step 3, assuming that H0 is true or under H0, our, okay, sorry, need to rephrase a bit. Okay, we are going to write down our test statistic. Yeah. So this is the test statistic over here. Okay. Okay, under H0. So assuming that H0 is true. Okay. Now because we are testing the sample mean, right? So we'll need the distribution of the sample mean. We need the distribution of X bar. So under H0, assuming that H0 is true, X bar from our sampling concept follows a normal distribution, right? With the population mean 500, and the the variance over here is going to be 20 square divided by a sample of 25 over here. Okay, something like this over here. Now, I'm going to write out one more step. Okay, I'm going to, and this one you don't really have to write it out, but I'm writing it out for the sake of comparison, so that because right, some questions require us to standardize to the standard normal distribution, right? So if we were to standardize this, our z, right, this z distribution would be X bar minus mean, okay, over this one. So 20 over 20 square over 25 square root. Okay, and this one, right, follows a normal distribution of 0 and 1, like that. Okay, so the concept is like this. Okay, so the concepts are like that. Okay, this one's over here. Okay, so something like that. Can So now once again, this standardization process, right, you don't really need to do, right, because we only do it when we are only required to standardize. So now currently, right, we are actually not required to standardize. We can just leave it like that. Okay, so technically we don't need this standardizing step for this particular question. Okay, so this would be step number 3. Okay, let's look at the next step. Step number 4, we need to state the significance level alpha, and we need to see what kind of tests are we taking. Okay, so back to this question step 4, right? Which kind of test are we taking? We will need to look at the alternative hypothesis over here, right? So this one is we are testing for more than 500. So meaning we're going to test on one side of the graph, right? So this is actually testing with a one-tail test, okay? And we need to test with this 7% level of significance, right? So our statement for the specific kind of test and the significance level will look like this. Okay, so taking a one-tail test, the right test at the 7% significance level, right? So this test, I would encourage everyone to write this test or to visualize this test using the bell curve, because this is following a normal distribution. So we will make use of the bell curve to visualize this whole test. Okay, so we will get something like this over here. So very quickly, right, let me mark out the region, mark out the population mean. So the population mean, right, or more like the bell curve itself, is symmetrical about the population mean. So because these are all values of the sample mean, or of the mean, so this is actually X bar, right? And the one in the middle is symmetrical about 500, which is our population mean. Okay, so this would be step 4, setting up, step 1 to step 4 to set up, right, the test that we are about to do. Okay, now step 5, let's finally carry out the test. So step 5, from the sample data, we need to calculate sample mean value or the p-value or the z-value, right? So from this point onwards, I will present to you three different ways to look at this situation. Okay, so let us do the first method first, which is our p-value method first. Okay, so back to the question over here, we will need to make use of this sample data over here to calculate our sample mean. Okay, so here I will present three different methods to do this. Okay, so now let's take a look at what we have from the sample. So from our sample, okay, so from our sample over here, right, let's calculate what is the sample mean first. So our sample mean over here would be the given data above, which is over here, 12625, right? So we have our 12625 divided by 25 loaves, right? So over here, the sample mean is 505. Okay, so now what we want to do is actually so let's say this is 505, right? Correct. So we are trying to see whether is it significantly far away from 500 or not, right? So in order to do so, we'll need to borrow our probability at 7%. Okay, so we need to borrow our probability at 7%. Okay, so how does this look like? It looks like this over here. Okay, so based on this so this area over here, right, this area on the right over here, this is actually 7%, right? So now I'm trying to figure out, right, is 505 over here, right? So if 505 is outside of the 7%, this means that it's actually not far away enough from 500, right? So that means the probability is still high enough to be within 500. Okay, now on the other hand, let's say 505 is over here. This means that there's a less than 7% chance that more like 505 belongs to the less than 7% chance, which is a very low probability for 505 to be within the sphere of 500. So this tells us that 505, having the low probability to within the vicinity of 500, right, is far away enough from 500. Okay, and because of that, we can decide whether is a claim true or not. So let's say if it's here, that means it is significantly away from 500. Okay, and we can accept that this is true. Okay, something like that. So we will look at the probability for 505, and we will see what how do we interpret this. Okay, now so for this, right, I'm going to borrow the help from our graphing calculator. Okay, and for our graphing calculator, right, it will look something like this. Okay, so the thing is there are many ways in which we can find our p-value, right? The first immediate way to find the p-value is we can go to statistics. Okay, we can go to tests, right? Because this is hypothesis testing, so we can go to test, and this over here is a z-test because we're using the z distribution, right, or the normal distribution. We're going to input our data as statistics, but this is for raw data. So input our data for statistics, then we need to key in our parameters one by one. So first one, mu naught, or the null hypothesis. This refers to our null hypothesis or the population mean. Now, this standard deviation over here, this sigma over here, be careful, because this application over here in our GC, right, helps us to do all the background work. Okay, and because of that, we will need to key in our raw standard deviation, which is 20. Okay, now do not make the mistake of putting in this whole standard deviation. Okay, now this sigma over here refers to the population standard deviation, so that they will do the back end calculation that includes this standard deviation. Okay, I will explain more later when we do this manually. Okay, now x bar over here we've calculated earlier. X bar is 505. Okay, we calculated earlier. N is 25. This, what kind of test is this? This is a more than test. So we are signaling to this calculator that we're doing a right one tail test to the right. So let's do some calculation, and we see that, okay, this is the z value 1.25, this is p value 0.1056, and so on. Okay, so I'm going to write down my p value over here. So from GC, right, p value is going to be equals to 0.105. Okay, and I will look at this p value, which is a probability, and compare this with 0.07. Okay, so this one, right, is actually more than 0.07. Okay, so this tells me that, okay, so what is this p value signifies? Okay, so I'll write this down in like pencil so that you don't have to write it down, okay, for your actual working, but I'm just writing down for your completion, for the knowledge. Okay, so what is this p value actually? Because we're taking a one tail test to the right, this p value refers to the probability where the x bar is greater than 505. Okay, so this is the probability that we are going to look for. Okay, because we want to check and see where is 505 and what is the probability, right? So this tells me that 505, right, is actually over here, because based on the p-value, this area that is shaded over here by 505, right, this area, the whole area over here is actually 0.105, right? And because the area is this area 0.105 is greater than 7%, right? So this tells me that 505, right, must be outside this red color region, right? So it means that this is outside the rejection region, or it is within the acceptance region. Or this tells me that 505 is close enough to 500. Okay, so once we get this, right, once we see that this happens, right, do we reject our null hypothesis or not? So means that we do not reject our null hypothesis, because this is not far away enough from the null hypothesis. So if this is false, if this is far away enough, then the Baker's claim is true. But from this test over here, this 505 is actually not far enough. Okay, so we are going to write down the conclusion below. Okay, we're going to write down the conclusion below, which is step number, number 6. We're going to look at the decision. Okay, step number 6, which is over here, decide on whether do we reject our null hypothesis or not based on the p value. Okay, so step number 6 over here, it is we do not, okay, because of this, right, we do not reject our null hypothesis. Okay, so this is number 6, because of this. Okay, and step number 7, we will state the conclusion of the test in the context of the question. So because this is okay, so because this 505 is not significantly far away enough from the population mean, okay, so we are going to say that there's not enough evidence at 7% significance level to support the Baker's claim. Okay, that the mean mass of the loaves of bread has increased after repackaging. So means it's not far away enough. So we can't say that the Baker's claim is true. Okay, so something like that. Okay, so this is our conclusion over here. Okay, so there's insufficient evidence at the 7% significance level and so on. Okay, something like that. Now let me elaborate a little bit more about the p-value, right? So the thing is that do we really have to use the calculator statistics way to do this, right? So this one is neat, right? Because it gives us the p-value, and at the same time it also gives us the z-value as well. Okay, it gives us the z-value as well. Okay, so it's like one shot I can calculate two things at one go, right? Now then again, right, the p-value that we've talked about over here, right, so this p-value refers to because we are looking for a one tail test to the right, so it's based on 505. We want to look at the area on the right hand side, right? So for this particular if we want to look for this probability itself, right, we can do it using our normal CDF, right? But so in our normal CDF, right, how does it look like, or what are the specifics that we need to key in. Okay, so if we'll be using our normal CDF, right, these are the set of things that we'll need to put in, right? So let's try and see, and let me show you what's going on. So I will go out, okay, I will go to the distribution. We're using normal CDF, right? The lower is 505, and we're looking to the area on the right hand side of 505. So this upper is going to be infinity. The mu, population mean, is 500, and the standard deviation, right, it will be the standard deviation of the distribution, because this one is not, this one we have to do everything from scratch, so we have to key in every single thing. Okay, as compared to just now. Okay, as compared to just now, because that one was an applet, or a function, right, a calculator function, we just key in the raw value and they will do the back end job of calculating this piece of sigma. Okay, so we don't have to key in this thing into the z test. This one you be careful lah. So the z test is everything bao ka liao, everything done for you, so you don't have to key in every single thing. But if you're doing normal CDF, you're doing from scratch, so we have to key in every single thing following the distribution. Okay, understand? So let's paste this, and voila, you can see that actually the probability is the same. The probability is 0.105, 649, and so on. If you were to go to statistics, right, you go to the test that we've done earlier, right, you can see that when you calculate, right, the probability is the same, 0.105. Okay, so technically there are two functions in the calculator that can help us to get this p-value. Okay, so once again, the p-value refers to this particular probability. There are two ways to get it. The easier way is to look at the test, z-test. The other way is to get from normal CDF. Okay, so this is method 1, the p-value method. Okay, so let's take a look at method 2, which is the critical value method, or the z-value. Okay, now, so the thing is, for this one over here, right, okay, how do we present our answer is the same, right, from our sample. Okay, our x bar is 12625, and this is going to be 25, and this is 505. Okay, so this is from the sample. Okay, then the thing is from our GC. Okay, from our GC, the same steps, right? The z value that we calculated up here, right? So the z calculate, right, that we have over here is actually 1.25. Okay, this one over here is actually 1.25. Can now, so the thing over here is that when we standardize to the z distribution, right, okay, so this one over here, the mean would be 0, it will be centered at 0, right? The z calculate over here is 1.25. Actually, I don't know where it's 1.25 lah. By right lah, I shouldn't know, but 1.25 is related to 505. Okay, so this one is we are looking at the z score. Okay, now then, after knowing my 1.25, right, technically speaking, I will need to check where is my critical region. So actually, before this, I need to add one more step. Okay, I need to find what is my critical region if I'm doing method 2. Okay, maybe let me write this on the right hand side instead. Okay, so I will need to establish my critical region, and the critical region, right, is we will reject our H naught, reject the null hypothesis. When, okay, when does this happen? Based on 7%, right, I need to find out what is this value over here. What is the z value over here? Okay, so, and how do I do this? How do I get this critical region, right? It's actually by looking at inverse normal. Okay, so I need to create, let me go to the distribution. I need to look at inverse normal. Now the area that I'm looking at is actually 7%, right? So 0.07. The mu is 500. Okay, the sigma is the whole sigma for the distribution, which is this one over here. Okay, so I'll put this in square root of 20 square divided by 25. Okay, now I'm looking at the right tail. Okay, and I will need to paste. Oh, sorry, wrong one, sorry. This is an inverse normal, standard. So this is 0 and 1, standard normal distribution. So 0 and 1. Okay, I need to paste. Okay, sorry, I need to delete everything on this side. Sorry. Okay, delete. Okay, can so this one is a standard normal, so the mean is 0, standard deviation is 1. Okay, so this one over here, right, I will get my z is greater than 1.48. Okay, when z is greater than 1.48. So this, when we look at this, right, this number over here, right, refers to 1.48. Let me move this to the left hand side a little bit. Okay, and this number here refers to 1.48 here. Okay, the z calculate is 1.48. Okay, and so this one, right, would be less than 1.48. Okay, and because of this, we'll get the same conclusion from the test. Okay, now once again, right, how do I get this number? Right, how do I get this number over here? Okay, this one I use inverse normal. Okay, now the area is 7%, right? This mean is 0 because it's a standard normal. The sigma is 1, and we are looking at the right tail. Okay, then right, because this one is actually from the z test, right? So actually, how did they get this 1.25? This 1.25, right, is actually a calculated value. So this z calculate, right, actually it is 505 minus the mean 500 over this number over here. So 20 over the standard deviation, 20 over 20 square over 25, whole thing square root. Okay, so this one, right, follows this particular formula over here. I will need to sub in my x bar. My x bar is 505. So 505 minus 500 over this. Okay, and this value gives me my 1.25. Okay, so this is how we get the values for the various processes for method 2. Okay, so this number here, 1.48, comes from inverse normal. This 1.25 comes from calculated value from the sample mean. And we compare and see that, actually the one in the sample mean, right, is less than the critical value. So it will be outside the rejection zone. Okay, so this will be method 2. Okay, so for method 3, same thing. Okay, it's the same thing. It's just that now we are looking for the same process, right? So from sample, okay, this one is 12625 over 25. Okay, so this one once again is 505, right? Okay, then from GC, right? From GC, right? So here, right, we will need to establish our critical region. Okay. Okay, so our critical region over here, right, is to look for our, okay, it's the same process as this. Okay, just that the distribution we are using the original distribution instead of this distribution. Okay, so this is what we are going to do for this method 3. Okay, so sorry, let me shift this a bit for method 2. So I'm going to shift this over here for method 2. Okay, so I'll label this one is for M2 lah, method 2. Okay, now for method 3, right, okay, we will need to also establish the critical region. Okay, and the critical region, right, is the same phrasing. We will need to reject our H naught when, okay, when our x bar, okay, is greater than this number over here. So how do I get this number? I will need to look for inverse normal. I'm going to do the same as before, this one over here, but the distribution is a bit different. Okay, so I'm still looking for 7%, but I'm going to use the original distribution of mean 500 and standard deviation square root of 20 square divided by 25. Okay, and looking at the right tail test also. So this one over here, right, when x is greater than 505.903. Okay, and so, right, because of this, right, looking at the sample, right, okay, looking at this sample over here, right, so this one over here, right, is less than 505.9. Okay, so technically, where is this? This is over here, this particular one, 505.903. Okay, and so because of this, the 505.9 is here, 505 should be on the left hand side, which is outside the rejection zone. Okay, and because of this, we do not reject H naught and so on. Now, so once again, how do I get this inverse how do I get this number again? I'm using the inverse normal function. Okay, same area, right? Because I'm looking for the critical region, which is at the shaded area. The mu is from the original data. This one is also from original data. Okay, from the original data. And we're also looking at the right tail test, something like that. Okay, so I'm just writing all this to show you the full working. Technically speaking, you only need to write the blue color part, which is actually very short. Okay, so there we have it, the full process of this hypothesis testing. It looks really long, right? It looks really, really long, but once again, I want to remind you, right, of the whole process. Okay, so the whole process looks like this. Step one, um, declare random variable and the population mean. Step two, null hypothesis and alternative hypothesis from the question, right? So null hypothesis takes the equal sign, then the other inequality would fall under the alternative hypothesis. Whose claim is it? Technically, sometimes the claim may be for the null. I think it depends, right? So, but I'll just write it down to help me to phrase my conclusion later. Step 3, writing down the distribution for the test statistic. So we are testing sample mean. So our test statistic is actually sample mean x bar, distribution of x bar. Okay. However, because we are looking at the normal distribution, so technically speaking, we'll be using the z test. Okay. The z test, then it depends on the question. So for a straightforward question, there's no need to standardize, but sometimes we'll need to standardize for a reverse question. Okay, now then step 4, we will need to state the test at how many percent significance level. Okay, and at this step also, we will need to look out on where is the critical region based on this 7%. Right? So based on the 7%, the critical region for the z-score is 1.48. The critical region for the raw sample mean value is 505.903, which can be gotten from inverse normal. Okay, so I will stand by my 500, stand by 505, stand by 148, or stand by this 7%. Okay, so I will get ready and set up these values over here first. Okay, so this will be step 4. Step 5 is now the test. So we have 3 different methods. The first method is to look at the probability on the right hand side. So because the probability of the purple shaded area is greater than the probability of the red shaded area, then the purple one is gotten from the sample, right? So we do not reject H naught. There is insufficient evidence. So means that the 505 is not far away enough. Okay. Method 2 is that we will need to calculate our 1.25. And actually 1.25 is less than 1.48. It's on the left hand side. So means that it is not far away enough from 500. Okay. Or method 3 is the 505, right, is before 505.9. So we cannot reject our null hypothesis. Okay. And based on this, we get our conclusion. Okay, so once again, this whole process, even though it's very long, 40 minutes, right? I try my best to explain every single thing under this concept. Okay, so hopefully these 40 minutes help you to sort out the basic idea of what do we do. Okay, and to do this specifically, right? I will see you in the next video to talk about the other questions and even the reverse question. So we'll be seeing some of these concepts again, but this particular video will house all the total concept for this whole chapter for a forward question. Okay, so hopefully this helps. I'll see you in the next video for the other questions. Okay, thank you so much and bye bye.